The previous video that you should have watched was a great explanation of why we have sampling distributions and what the standard error of the mean is. And so with that being said, once we know what sampling distributions are and how they're created, we can use kind of what we know about probabilities to calculate point estimates and find out how reliable those point estimates are. So today we're going to talk about one such point estimate, a confidence interval. So one of the things that we are doing now is we are moving from descriptive statistics to inferential statistics. So prior to now, everything that we have done has been about describing a sample and describing kind of what the respondents to the sample said. And now we're looking at how likely it is that that sample selected is representative of the population. So we're trying to make an inference from the sample to the larger population. Now, researchers can never know with 100% certainty whether their sample is representative or not. And so we use various statistical techniques and what we know about the normal curve and probabilities in order to help us to determine whether or not our statistics are a good fit. So one of the things that we oftentimes use are what are called point estimates. And a point estimate is any characteristic of a sample that we're using as an estimate of a population parameter. So in this case, we're talking about the mean or the center point of the data. And so a point estimate is where we take the sample mean and we say that the sample mean is representative of the population mean. So how do we know whether or not our point estimate is a good generalization to the population? How do I know that my sample mean is a good representation of the population mean? And so one of the ways that we can do this is by utilizing what's called a confidence interval. So the confidence interval consists of two parts, the interval and a level. The confidence interval is a range of values within which a given population parameter or characteristic is likely to fall. So in this case, the mean. So we're going to look at a range of values where we think the mean is likely to fall. And the confidence level specifies how likely or how probable it is that a population parameter or characteristic will fall within that interval. So this is the likelihood. So we can get as precise as we would like. So we can have a 99% level or a 95% level where we are 99 or 95% confident that the interval we have contains the population mean. We can never get 100% confident unless you have a range that goes to infinity, but we can get very close. One of the ways that we are able to specify our confidence levels, and one of the ways that we are able to kind of talk about this is with what we know about the normal curve. So take this normal curve, for example. These SZs, these are standard errors or standard deviations, if you will. And so if this is a sampling distribution of means, this is the mean of that sampling distribution, and that is 0 standard errors or 0 standard deviations away from the center. And then as we go out, there are certain things, qualities that we know about the normal curve, right? So we know that within 1 standard deviation or 1 standard error above the mean and below the mean, we know that that is 68%. And we know that going out to almost 2 standard deviations or standard errors, that's going to give us 95%. So that's where this green mark is here. And then we know that going out to 2.57 standard errors or standard deviations, that's where 99% of the variance or the population lies. And so what we can do is we can kind of estimate or figure out what is the likelihood that our sample mean falls within these kind of red areas down here at the end. So what's the likelihood that the mean that we have or the sample that we have drawn is an outlier? What's the likelihood that our sample is unusual rather than being kind of a part of the norm? And so that's what we're talking about when we're talking about confidence intervals. So we're going to find a range that will kind of tell us how likely it is that our mean is within this kind of larger area here rather than in the tails. So that's what we're doing with a confidence interval. How do we go about calculating a confidence interval for the mean? We use this equation. So in the last video, they talked about how to find the standard error of the mean. In other words, the standard deviation of the population mean, the mu. And so the standard error of the mean is this little guy here. That's the symbol for variance of the mean. And so this is calculated by taking the standard deviation of our sample and dividing it by the square root of n. And that's how we estimate the standard error of the mean. And so our equation for a confidence interval, we're going to take the mean from our sample and we're going to add and subtract because we're talking about an interval. So that interval's got an upper bound and a lower bound. And so we're going to add and subtract z times the standard error of the mean, which is standard deviation divided by the square root of n. So we can calculate the mean, we can calculate the standard error of the mean, but what are we talking about with this z? Well, this z is going to be dependent on what level we're looking at. So if we are looking at a 95% confidence level, then z equals 1.96. If we're looking for a 99% confidence level, then z equals 2.57. And this is based off of the normal curve that was on the previous slide. And that's where we get those numbers from. So these are numbers that you just memorize. You don't have to look these up in a table. These are just things that you should remember as you go along. Now, the reason why we use a 95% and a 99% is those are the two most common used, and those are kind of the benchmarks for social science research, is the 95% and the 99%. Sometimes you'll see a 90% confidence level, but while it's not as useful. And so generally these are the two that are most acceptable in our fields. Do an actual example. And so here I'm giving you the mean, I'm giving you the standard error, and then I've also given you the z's. So we're going to calculate first a confidence interval for a 95% confidence level, and then we'll also do one for a 99% confidence level. So let's start with the 95%. So for 95%, I'm going to use the z of 1.96. So my equation is going to be the confidence interval upper, so this is the top of the range, is going to equal the mean, 22, plus z, 1.96, times the standard error of the mean, 0.58, and then we're going to go ahead and calculate that out. So we're going to have 22 plus 1.14, which equals 23.14. So that is our upper bound for this equation, or for our confidence interval. So then, for our lower bound, our confidence interval lower is going to be 22 minus 1.96 times 0.58. And that equals 22 minus 1.14, which is 20.86. So our confidence interval then for a 95% confidence level equals 20.86 to 23.14. So this is the range of values that are the real mean for the population is likely to fall in this range. So how likely? 95% likely. And so there are only 5 chances out of 100 that the sample mean will be outside of this range, or that the population mean could actually be outside of this range. And so that's pretty good. Okay, let's go ahead and do a confidence interval for 99% level with this same data. So working with the same data, we are going to be doing a 99% level. And so we're going to have the confidence interval upper is going to equal 22, that's our mean, plus this time 2.57 times the standard error, which is 0.58. And so you're going to have 22 plus 1.49, which equals 23.49. And so then for our lower, we're going to have the mean, 22, minus z, which is 2.57. And remember, I got that z because of what we know about the normal curve. And so it's just something that I know. And we're going to multiply that by the standard error of the mean, 0.58, which was given. And so we're going to have 22 minus 1.49, which equals 20.51. So our interval is 20.51 to 23.49. And so that is our interval. So how would I interpret this? Let's talk about that for a second. So the way that I would interpret this is that I would say, for the 95% confidence interval, I would say there are 95 chances out of 100 that the age interval between 20.86 and 23.14 years contains the population mean. So I'm taking that lower bound and upper bound from the confidence interval and just plugging those in. And then for the 99% level, we're going to say there are 99 chances out of 100 that the age interval between 20.51 and 23.49 years contains the population mean. So if you're comparing these two, what you'll notice is that the 99% confidence level allows us to be more certain that our population mean is going to fall within that range. We're 4% more certain, so 99% as opposed to 95. However, there is a drawback to this. The range is wider, and so there's kind of more room for variation. Now in this case, because we had a very small standard error, there's not a lot of difference between these two. So we're talking about 20.51 as compared to 20.86. That's not a whole lot of variation, and that's because we have a small standard error. And so the 95% confidence level, we're less confident, but it's a smaller range. And so there's a trade-off there. All right, in part 3, we're going to talk about what do you do when you don't have a mean. So what do you do when you're dealing with nominal or ordinal level data?